All right, so now let's estimate the durations. All right, so now we're basically going to take that network diagram and we're going to figure out how long it's going to take. Right, now, John, a little bit different because in version 5, we would estimate activity resources first and then estimate the durations. Now in version 6, they're saying, well, you don't necessarily need to estimate the resource type. You can figure out how long this activity is going to take or estimate it without having known exactly what resource you're going to use. All right, so, but you'll see how we'll take some of the inputs from that process, and it just gives you another example of how we jump back and forth from process groups. And even within a process group, we'll jump back and forth between knowledge areas. All right, so just remember, developing your project management plan is iterative, and that's that term that PMI will use, and I'll also call it progressive elaboration. All right, we'll progressively elaborate, so we're always updating and refining it. All right, we're actually going to use these durations to actually develop the schedule. So later on, we'll take this as an input and we'll create the schedule and the schedule baseline. All right, so let's jump in. These are the tools and techniques we're going to look at. We'll take the plan. We'll take these various documents into account. And you can see here how some of these we haven't gotten to yet. Oops. Some of these we haven't gotten to yet. We haven't gotten to a resource breakdown structure or resource calendars or resource requirements because we haven't estimated those resources. So the idea is that, well, you can go and jump to that process and then come back to here and update it, or do that process first and come back here. But, you know, same thing with the risk register. We haven't technically gotten to that process yet in our journey. But if you have, then you take this into account. All right, EEFs, we'll look at these tools and techniques, these estimating techniques, analogous, you know, someone here you might want to mark if you have the book, analogous, let's see, bottom up is the most accurate method of estimating. The least accurate is analogous. I'm just going to make a note of that.
CJ, do you have an example of analogous estimating that you could share?
Okay, I'm thinking, and thank you, analogous, like an analogy. So, okay, we did a project like this last year for this client, and it took us 6 months, and it cost, you know, $500,000. So this project's going to take about 6 months to cost $500,000. All right, this project is like that. We're going to jump in. We're going to deep dive into all these.
Okay, we do that. Analogous estimating is probably the most prominent estimating that we do in our line of work, honestly.
And there's times there's times where it's appropriate. Analogous estimating is very appropriate for the very beginning of the project.
Right. We'll do that as like a first cut with a client, and then we'll do bottom-up estimating before we, you know, get a contract in place.
You're already following the PMI process, you know, literally. All right, let's see it. The output here, sorry, because we are gonna talk about each of these. So let me just level set because it has been a week. As we go through each process, what we'll do is we'll start and we'll talk about what's the essence of this process. What are we trying to accomplish here, right? That's what we'll start with, and then we'll show you the inputs, tools, and techniques and outputs that we're going to talk about. But we'll start with the outputs. We'll start with what we're going to create. So that way you kind of begin with the end in mind, and then we'll talk about the tools and techniques that it took to actually create that. So that's how it will go. So if you see here on the next slide, we get to the key outputs, the duration estimates. All right, estimate activity durations. What are we going to get? We're going to get the duration estimates. So that'll be the name of this output. And it's just a numerical, it's the number, and it can be a range for PMI. Right? It does not need to be just a number. It can be a range. Now, your estimates also aren't going to contain any lags. Right? Your estimates from your team members on the exam are supposed to be exactly what they are. You take it at face value. Remember, the assumptions are you're in a strong matrix environment, 200 resources, year-long project, $10 million budget, and you're an assertive project manager. But also that, you know, management isn't working against you; they're working with you. All the documentation is well kept. You know, people are honest, and you know, so take this very utopian view when you're taking the exam, and recognize that when people give you estimates, there's no buffer time built into it. There's, you know, it is a true estimate, you know, versus in the practical application, it depends on who's giving us the estimate where, you know, we may ask, you know, some additional questions. All right, so the basis of estimates is also another key output. We'll see this when we estimate cost, same thing. We want to get, how did we get to this number? It's the logic behind, you know, what data sets did we choose? Why did we come up with this, well, you know, with this number? Where did we even get the idea to, you know, to use this information? All right, so that's the basis of estimates. We'll create one of these. Again, it can be a range as well, or it can be a confidence interval, and we'll see that when we get to 3-point estimates. And we may we'll update some project documents. Right? Remember, this is always potential, but at this point, since we're creating the project management plan, literally every time we create something, we are updating the document. So, you know, there may be some assumptions, there may be some attributes that we figure out and we learn, you know, aside from the durations. It could be, you know, a different dependency type or relationship that we come up with. You know, even how we estimate, you know, in terms of lessons learned. Oh, this is a better way of doing it. Right, the inputs that we'll take to do this, we'll take that activity list and the attributes, right? Because, you know, we need to know what types of activities they are and what their dependencies are, and that's also gonna, you know, be a factor in how long we think it's gonna take. We'll figure out which ones were significant points and times. We'll take that resource breakdown structure, resource calendars, and resource requirements. Those are outputs from estimate resources. That process is in the resource knowledge area. We'll see that in about 5 or 6 processes from now, right? So those outputs are from that process. They become inputs to this process. And then any logs, assumption log, risk register, lessons learned log, we'll take that as an input as well. All right. EEFs and OPAs we will take into consideration as well. And if you think about EEFs in durations, just maybe it could be the infrastructure. How long does it take to get, you know, to travel, or, you know, can we get, you know, heavy machinery down this road? And then OPAs, right? Your company could already have past estimates or, you know, folks who do this work continuously, and we can go and look at other project files and get an idea of how long it took. Right, now here's the estimating techniques that we would use on those inputs in order to get the duration estimates and the basis of estimates. We would analogously estimate, and that's where you take some data from a past project, and we talked about that one. Well, this project was like this, so that project will be like this too. Parametric takes a slightly different stance. I won't say it's more accurate than analogous, but it's certainly, we can't call it accurate by any stretch of the means. But what parametric is it says, okay, our last project for this client was similar, but it was only a third of the scope. Therefore, since this one is 3 times, then it's going to cost, you know, 3 times as much and take 3 times as long. You actually take some data, some statistical, you know, relationship to come up with that estimate. So that's parametric. So in the sense of this project was like this and this project was like that, you would literally say, well, this project is 0.92 of it or 0.97 to do the parametric. And then 3-point estimating, there's 2 types. Let me see if we get into it. Yes, we are. We're going to get into each of these. So 3-point and then bottom up is the most accurate here. All right, so here's some examples of when you would use analogous estimating, when you might have limited detail. But reliable when previous activities are similar in fact, not just appearance. So if you're doing projects of the same nature all the time, analogous estimating is perfectly acceptable. It's what you should be doing. It's the quickest, it's the least costly. We see that at the bottom. Right? Yes, it's the least accurate, but if you know that you're within, a standard deviation or something like that, well, then this is what you want to go with. Okay, then parametric estimating, we just talked about this, is, we actually use some sort of statistical number. So they give you the example here, 2 labor hours required per square foot. Well, you figure out you need 100 square feet, then it's going to be 200 labor hours. All right, that's the parametric piece. 3-point estimating. You will need to memorize this formula. All right, so in this, the equation equals your optimistic plus the most likely plus your pessimistic divided by 3. Right, now, another way, right, we have the TE. Another way to it should just say optimistic plus most likely plus pessimistic divided by 3. That's literally what it is, right? So take 3 numbers, divided by 3, and you get the average. That is called the simple, or triangular. Those are the 2 terms for that. That's simple or triangular. Okay. Now there is another 3-point estimating, but I think we're going to show it when we get to cost, right? And it's the beta or PERT, and it's where I'll just show it to you now, but we'll deep dive in when we get there. It's where you take your optimistic plus your most likely times 4 plus your pessimistic, and then you divide it by 6, right? So this is called beta or PERT. Make a better 6 there. And this is called beta or PERT. PERT for the Performance Evaluation Review Technique. It's made popular by the Navy. The Navy is the one they use PERT all the time. And when we get into this, there's a few other things you'll have to recognize. You'll have to memorize, I should say. To find the standard deviation where you do your pessimistic minus optimistic divided by 6, and then that's where we'll use standard deviation. So when we get to a cost, we'll see this, but I want you to know that there's two ways to do 3-point estimating. So the exam isn't, they're not going to tell you which one. So just understand that, when they're describing it, either they're going to ask you for a simple or triangular, what we see above, just 3 numbers, or they're going to ask you for a beta/PERT, beta or PERT, and that's where we take 6 numbers. All right, so those are the 2 ways that we do 3-point estimating. We can also bottom up estimate. Bottom up is the most costly, takes the longest, but it's also the most accurate. So questions on exam that'll describe, you'll give you like 8, 9 lines of text, this big old paragraph, and then it'll say what's the most accurate method of estimating. And this is why on the questions on the exam that are really long like that, many times you can just read the last sentence, and that is the question. What's the most accurate method of estimating, right? You don't need the other stuff. It's just to confuse you, right? And it's going to be bottom up. Bottom up is the most accurate, but it's also the most time consuming and it costs the most. Whereas analogous is the least accurate, but it's the quickest and it costs the least. All right. There's also the alternatives analysis when we estimate the durations. And this makes sense too. This is sort of like, well, what if we used senior engineer versus junior engineer? Or what if we used a heavy machinery instead of manual labor? What if we outsource this versus insource this, et cetera, et cetera. You see some other stuff here. What if we compress the schedule? What if we fast track? Things like that. So that's the alternatives. And then reserve analysis, we also have to look at these durations, and we have to think about, well, what may happen, and if so, what might that do to the schedule? We got to think about, how much time should we allocate, for risk analysis to the schedule. And we're going to deep dive into reserve analysis when we get to risk, right? Because we'll go real deep. We'll identify the risk, we'll qualify it, we'll quantitatively analyze it, and we'll come up with the reserve analysis. But for each process, especially when we estimate in terms of durations and cost, we'll do it individually as well. And so that's the idea here, is we're looking at risk and we're trying to figure out, what percentage of the time or what set day of time should we be putting aside. And then there's 2 types of reserves. Contingency reserves. We own these, right? As PMs, we own these. We can foresee these. They're known unknowns. We don't know that it's going to happen, right? Or I should say this, we know that it may happen. It's just unknown if it will and to what degree it's going to impact the project, right? Management reserves, this is owned by management. And these are just the unknown unknowns, and this is stuff that we don't know, and it's unforeseen. We didn't know that there was going to be a strike in public transportation, right? We didn't hear any rumblings about, this in the news. And so, now 40% of our workforce can't get there. So that's the unknown.
CJ.
Yes.
For the contingency. So if I have control over the budget of that money, then is a contingency reserve. If I have to go to management to get the money, then that's a management reserve?
Yes.
Okay.
And this also, and we're gonna the same estimating techniques we do for the schedule, like literally these same slides, we're gonna see the same text for cost, because we do the same things for time and for money. And when we get there, we'll see how when we build the budget, right? We're gonna build the schedule baseline. When we build the cost baseline, we don't own, like, we call it the budget, but what we're calling the budget, PMI for us is the cost baseline. And then management reserve sits on top of that cost baseline, and that becomes a total project budget. Many times we as PMs, we don't know what that number is, because we don't know how much management is willing to put in to continue, this project beyond what they thought it was gonna cost, right? So that's for the unknown unknowns, things that we can't foresee. But the things that we can foresee, we can build that in, and we can build that buffer into our project. That's considered the cost baseline, and we own that. So contingency reserves, cost baseline, versus management reserves, project budget. When we get to cost, I'll tie that in again, but I want to mention it now so that we hear that terminology. Okay. So let's look at a question. You are the project manager of a project to develop a new organic energy drink. You are estimating the activity time required for obtaining a new formulation that meets organic standards and is chemically stable. The most likely estimate is 15 days. The most optimistic is 13 days. And the worst case is 23 days. What is the estimated activity duration? How would you do this? Not worried about what the numbers are, but just how would you solve this?
I'd add the 3 and divide by 3.
Pretty much. All right. Now there's another way that they may give you the same question.
Mm-hmm.
100, this could be question 17, and then question 117 will say at the end, instead of saying what is the estimated activity duration, it'll say using beta or using PERT, what is the estimated activity duration?
Yeah. Then we just multiply the 15 by 4 and divide, and then add 13 and 23 and divide by 6.
Perfect. Yep.
Yeah.
And you'd get slightly different numbers because now you're placing more weight on the most likely.
Right.
So we'll see those questions coming up. Okay. So that's the duration estimates. You got it right. Take your 3 numbers, divide by 3, but there's another way, and you got that right too.